What was the correct substitution here?
Negative x3.
Sorry?
Negative x cubed.
That would be fine, perfectly acceptable, you could do that. So I want to find first the anti-derivative. I'm not going to change the limits of integration. I'm not going to change the limits of integration. So we want to find first the anti-derivative of this. So you make the substitution u is equal to negative x cubed, the derivative being so that come here and try to change it. And happily the x squares cancel. And if there was no cancellation, it would be the wrong substitution, or u substitution is just not going to work. So we have negative 1/3. du du. Okay, well, what is the antiderivative of e to the u? du? E to the u. So here's the antiderivative, which is what we're using. That would be the exact area. Yes?
Is it plus or minus?
Where?
Where you have the
Minus, minus. Plus. Okay. Dr. J's are you are not. Huh?
Where's the plus?
Ah! Go and check your calculus 1. This is a definite integral.
Oh, yeah.
You'll do c minus c. Huh? C minus c, right?
Okay.
Oh, well, if you want. Good point. You're all adults now, right? Woo! Okay?
Right. I got you.
Okay. Let me do a quick review of linear approximation. I don't know, we may need it later on in the semester. But it's something a lot of people have trouble with. And then I will end the review. We'll study some integration techniques. Linear approximation. It is a very simple concept. You approximate a function at a point with a line. That is, you are approximating a nonlinear function at a point with a line. You can't approximate it with any old line. It better be the tangent line. So here's a function. Give me a function. Huh?
x cubed.
Yes, f of x equals,
X cubed.
good, f of x equals
Sine of x.
whatever. Function in your hand. Non-linear. You would like to approximate that function here. Give me a point.
3.
X equal to?
3.
Oh, I had lots of points. Whatever your point is. Okay, your point is 2 and his point is 3, I don't know. Now, I want to approximate that function at that point with a line. Why? Because people like lines for some reason. Things that are not lines are quite complicated. So it seems to me that if you were to approximate this function here with a line, it would be that line there. And it's not a bad technique. Us economists, they believe everything is lines. You see there's really not much difference. Provided you're close. Now, if you chose some other line, then who knows what you're doing. It's a bad approximation. So you want the tangent line. Now we say approximation of a nonlinear function at a given point. It's really a local problem. So our function here is now, if you are close to x0, the line and the curve are very, very similar. But if you were to go very far, then the line and the curve would not use the line to approximate your function anymore. Now, this thing here is given. Your function y equals square root x, quite nonlinear. And you will want to say, well, now, for example, you would have to use this line, this, to find this thing here. What is the y value here? Square root of 4.1. Not nice. Anybody know how to find the square root of 4.1 without a calculator?
Yes.
How do you estimate the square root of 4.1? You try 2.1. 2.1 times 2.1. Huh?
4.2.
Too big. You try maybe 2.05 times 2.05. 2.05 times 2.05. 2.025 times 2.025.
Then you're just wasting paper.
Huh? It's too big. Huh? Close enough, but still too big. Yeah, 2.025 is not bad. Maybe you'll try 2.023. How do I find the equation of this line? Well, you're going to ask your college algebra friends. They say, give me the slope and give me a point. Well, who can give me a point on this curve? Huh? Oh, the point. There's two things.
Oh.
Y and x. X0, f of x0, being a point in your hand, not x and y. 4.1 and f of 4.1. Who will give me the slope of this line?
Mr. Derivative.
Ah, yeah. No, don't tell your college husband friends that. They don't know what you're talking about. But you tell them there, the slope of the function is the derivative function evaluated at that point. And you spend quite some time in calculus one doing that. The slope of this line is the derivative at that point. So that my line. Yeah. Now your college algebra friends are jumping up and down. They know how to deal with us. Then they say, take the y minus y1, take the slope multiplied by the slope, and x minus x1. Y minus y1 is m times x minus x1. That is it. Nothing mysterious about it, you know a little bit of calculus. And this is a line. May look quite terrifying, but it is a line. Like y minus 3, y value in your hand is slope in your hand. The slope of tangent line is 9.